We've been talking in this class about what we call descriptive statistics, and we're getting ready to make the jump to inferential statistics, where we use some sort of small sample to try to make predictions about a larger population. And in order to do that in any reasonable way, we're going to have to know something about probability. Okay? Inferential statistics is based on probability when you use random sampling. So we're going to look at a couple of chapters here in the book on probability. Okay? We're going to start with one that's on what we might call basic probability. So we always start with kind of the most basic example we can think of. What if you toss a fair coin? Okay, if you just toss a fair coin. What if you did it 10 times? How many of the tosses do you expect to be heads? Okay, so let you think about that. Now I have here a little GeoGebra applet I made that lets me simulate a coin toss. I can click the button here, toss the coin, it'll toss it. That was a head. I can toss it again. I'm sorry, that was a tail. Toss it again. That one's a head. And so I can keep tossing it and keep track. Let's do it 10 times. So we wound up with 3 heads and 7 tails. Is that what you thought? Well, what we call the theoretical probability is we would expect 5 heads, 5 tails, because each time we toss a coin, there's a 50-50 chance. There's 2 possible outcomes. One of those is a head, one is a tail. So that's what we're going to talk about is probability. That doesn't mean if I toss it 10 times, I'm always going to get exactly 5 and 5, as we can see here. But the idea of probability is if I do it a large number of times, let's say I do it 1,000 times and see what happens. And it's not perfect, but look, it's pretty close, right? We got 49.9%, 499 out of the 1,000 were tails, 500 or were heads, 501 were tails, so very close to 50-50. So the idea of probability is that for certain types of events in the long run, we can make pretty good predictions about what's going to happen. Okay? And it is a long-term activity. It never tells you exactly what's going to happen at any given time. So probability is for what we call chance behavior. Chance behavior is unpredictable in the short run, just like tossing the coin 10 times. I can't predict exactly what's going to happen, but it has a regular and predictable pattern in the long run. The more times you do it, the more likely it is it's going to start to level out at what we call the probability of that event. So we call a phenomenon random if individual outcomes are uncertain. Every time we toss the coin, it's uncertain whether we'll get a head or a tail. But there's nonetheless irregular distributions of outcomes in a large number of repetitions. The probability of any outcome of a chance process is the proportion of times the outcome would occur in a very long series of repetitions. So there's a couple of myths about randomness that the textbook points out. One of them is what I was getting at with the applet there, the myth of short-run regularity. Probability tells you what happens in the long run, not in the short run. I could toss a coin 10 times, and if it's a fair coin and I'm tossing it completely random, you could have anything from 0 to 10 heads occur in those 10 tosses. But in the long run, if you do it 1,000 times, 10,000 times, you expect it to be pretty close to 50% of each. It's also very closely related. You have the myth or the law of averages that, like, say I've tossed the coin 10 times and I've gotten like 8 or 9 heads, then you think, well, I've got to start getting some tails for it to even out. And in the infinite long run, yes, but every single time you do a random event, all the outcomes are equally likely. So let's develop some terminology. Okay, so the set of all possible outcomes, we call that the sample space, which could be incredibly complicated, but in the case of tossing a coin, your sample space would just be a head and a tail, the 2 possible outcomes, so the set containing those 2 things. An event is any single outcome that you could get, okay, or any subset of the sample space. Example, tossing a head is an event. Tossing a tail is an event. And then a probability model is like a complete description where you would have the sample space and then the probability of each outcome in the sample space. So for tossing a coin, it's 50-50. You have a 1 in 2 chance of tossing a head, a 1 out of 2 chance of tossing a tail. So the probabilities are 1/2, 50%. And you can represent probabilities any of those ways. You can say 1 out of 2, 1/2, 0.5, 50%. Those are all mathematically equivalent. Here's a little bit more complicated one that our textbook had. Give a probability model for the chance process of rolling 2 fair 6-sided dice. So we could do 1 dice, and then our sample space would have 6 things in it, 1 through 6. If we roll 2 of them and the order matters, and here they've colored 1 red and 1 green so that there's definitely a difference there in the order, you wind up with 36 outcomes in your sample space that you can see here, 6 times 6. So you get a much larger sample space on that example. So your sample space has 36 outcomes. If they're all equally likely, then any single one of these events occurring has a 1 in 36 chance of happening. Like rolling snake eyes, a pair of 1s there, it's a 1 in 36 chance that that would happen. So we get our definition for probability, and I will mention we're really talking right now about things that are discrete that you can count up, okay? So if an event E can happen in k ways out of a total of n equally likely possibilities, the theoretical probability of the occurrence of the event is denoted by k over n, the number of successes, the number of events where what you're looking to happen happens out of the number of possible outcomes. For example, the really simple case of tossing a coin, the probability of a head, well, there's only one outcome where it's a head out of 2 possible outcomes, head or tail. So you have a 1 out of 2 chance. So that's the basic definition of probability when it's discrete and you can count it up. It's the number of, now we call it successes, where a success might actually be a bad thing, but it's whatever you're counting the probability of. It's the number of ways that can occur out of the number of possible outcomes. So if you toss a coin, you got a 50% chance of a head each time. So let's do a simple little discrete example here of basic probability. So if I have a bag that has 5 white chips and 7 red chips, and I randomly select 1 chip from the bag, what is the probability of? So we have a few different things here. Part A, what's the probability I get a white chip? Okay. Well, in that bag, there's 5 white chips, and there's a total of 12 chips. 5 plus 7 gives me 12 chips. So quite literally, we have a 5 out of 12 chance of getting a white chip. So the probability of a white chip would be 5 out of 12. Sorry, my animation got away from me there. Part B, a red chip would be 7 out of 12. There's 7 red chips out of the 12 chips. Part C, what's the probability of not getting a white chip? Okay. Well, in this specific case, if you look at it, there's only two possible things that could happen, right? You get a white chip or a red chip. So if you don't get a white chip, it's the same as getting a red chip. So the probability of not getting a white chip would be 7 out of 12. There's 7 of the outcomes where you don't get a white chip, which happens to be when you get a red chip. We will mention the probability of something not happening is 1 minus the probability that it does. And you can see that in this case. 1 minus the 5/12 would give me the 7/12.